Welcome to the Bare Metal Cyber CCISO Prepcast. This series helps you prepare for the exam with focused explanations and practical context. Encryption is one of the most important tools in the cybersecurity toolbox. It plays a central role in protecting the confidentiality of data, whether it is stored on disk, transmitted over networks, or used in applications and services. By rendering information unreadable to unauthorized parties, encryption reduces the impact of breaches, limits the exposure of sensitive data, and preserves trust. It is essential for meeting regulatory requirements across sectors, including healthcare, finance, and government. Encryption also enables secure authentication, integrity verification, and safe communication in digital business operations. Whether protecting payment data, medical records, intellectual property, or cloud workloads, encryption reinforces digital trust and supports a secure enterprise foundation. The CSO is responsible for setting the organization's encryption strategy and ensuring it is consistently implemented across systems, teams, and environments. This begins with developing and maintaining an enterprise encryption policy that specifies where, when, and how encryption is applied. The CSO ensures that appropriate encryption algorithms and key strengths are used based on risk, sensitivity, and compliance needs. This responsibility includes reviewing encryption coverage for data at rest and in transit, ensuring that key management practices meet industry standards, and overseeing any encryption exceptions or compensating controls. The CISO also monitors encryption metrics and reports exceptions or weaknesses to executive leadership. As business environments change and new systems are adopted, the CISO plays a key role in updating encryption standards and ensuring alignment with risk and compliance goals. To manage encryption effectively, security leaders must understand key technical concepts. Symmetric encryption uses a single key for both encryption and decryption. This method is fast and efficient, making it suitable for large volumes of data. A common symmetric algorithm is AES, which is widely used for file and database encryption. Asymmetric encryption, on the other hand, uses a key pair, a public key and a private key. The public key is used to encrypt data, and the private key is used to decrypt it. RSA is a common example. Asymmetric encryption enables secure key exchange and supports digital signatures. Hashing is another important technique used for verifying data integrity. Hash functions such as SHA-256 create a fixed output that changes dramatically if the input is modified. Digital signatures combine hashing and asymmetric encryption to verify identity and prevent tampering. TLS and SSL are protocols that apply encryption to network communications, protecting web traffic and secure APIs. Understanding how these mechanisms work and when to use them is essential for managing encryption risk. Encrypting data at rest helps protect information stored on systems, devices, or media. This includes full disk encryption, which encrypts entire drives, commonly implemented using tools like BitLocker for Windows or File Vault for Mac OS. File-level encryption provides more granular control by protecting specific files or folders. Databases can use transparent data encryption, or TDE, to encrypt data files and logs without requiring changes to applications. Endpoints such as laptops and mobile devices must be encrypted to reduce the risk of data theft if lost or stolen. Key management is vital to all of these approaches. Encryption is only as strong as the keys protecting it, and those keys must be securely generated, stored, and rotated. The CISO ensures that data at rest is encrypted according to policy and that key management procedures are monitored and validated. Encrypting data in transit is equally important. This protects information as it travels over internal networks, public internet connections, and private links. Common protocols include TLS for web and application traffic, HTTPS for secure websites, IPsec for virtual private networks, and SSH for secure terminal access. Email encryption can be implemented during PGP or S/IME to prevent unauthorized reading during transmission. Remote workers rely on encrypted VPNs to safely connect to enterprise networks. All these methods depend on certificates and keys to validate identities and establish trust. Certificate management must include renewal, revocation, and chain of trust validation. The CISO oversees these mechanisms to ensure that transmitted data is protected from interception, tampering, or exposure. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Key management is the backbone of any encryption program. It includes generating strong keys, distributing them securely, and controlling their use. Hardware security modules, or HSMs, provide physical protection for key storage and cryptographic operations. Cloud services also offer key management systems, or KMS, which allow organizations to manage keys centrally. Policies must address how keys are rotated, when they are retired, and how they are recovered in the event of system failure. Access to keys must be tightly controlled using role-based access controls and logged for audit. Poor key management can render encryption useless if keys are lost, misused, or exposed. The CISO ensures that the entire key lifecycle is governed by clear policies, secure infrastructure, and regular oversight. Regulations across industries mandate or strongly recommend encryption. The Payment Card Industry Data Security Standard, or PCI DSS, requires the use of strong encryption to protect cardholder data. In healthcare, HIPAA encourages encryption of protected health information and provides breach safe harbor when encrypted data is exposed. Under the General Data Protection Regulation, or GDPR, encryption and pseudonymization are recognized as safeguards to protect personal data. U.S. federal systems often require FIPS 142 validated encryption modules. The CISO ensures that encryption policies reflect these requirements and that audit evidence can be produced when needed. Compliance documentation should map encryption controls to the applicable regulatory mandates, and exceptions must be justified and formally accepted. Organizations face several common challenges when implementing enterprise encryption. One major issue is incomplete coverage, such as unencrypted backup systems, misconfigured cloud services, or unmanaged endpoints. Key management problems are another common pitfall. Poor storage practices or lack of rotation can expose sensitive keys. Legacy systems may suffer performance degradation when encryption is enabled, creating resistance from operations teams. New technologies such as containers, IoT devices, and SaaS platforms often introduce data types or environments where encryption is harder to implement. Lastly, encryption can give a false sense of security when not paired with strong access controls. If access permissions are too broad or not logged, encrypted data can still be exfiltrated by authorized insiders or compromised accounts. The CISO must identify these gaps and take a risk-based approach to prioritize remediation. In modern environments, encryption must extend to emerging technologies and cloud platforms. CloudNet KMS solutions from providers like AWS and Azure allow organizations to manage keys in cloud workloads. Bring your own key, or buy OK, models let companies retain control over cryptographic material. Some opt for hold your own key, or HYOK approaches to eliminate provider access entirely. Messaging platforms increasingly support end-to-end encryption, ensuring that only the sender and recipient can read content. Organizations must also consider post-quantum cryptography, anticipating that future quantum computers could break current encryption standards. This requires algorithm readiness and vendor evaluation. Tokenization and homomorphic encryption offer advanced options for protecting data during processing or sharing. The CISO ensures that encryption strategies remain current and adaptable to new risks and technologies. On the CCISO exam, encryption is tested through definitions, scenarios, and decision-making. Key terms include symmetric encryption, asymmetric encryption, hashing, TLS, KMS, and transparent data encryption. Scenario questions may involve selecting appropriate controls, responding to a compliance requirement, or addressing a key management failure. The CISO's role in encryption governance, architecture approval, and policy enforcement is a key focus. Candidates must understand how encryption integrates with risk management, audit readiness, and regulatory compliance. Demonstrating strategic understanding of encryption, not just technical knowledge, prepares leaders to implement scalable, reliable, and compliant encryption programs. Thanks for joining us for this episode of the Bare Metal Cyber CCISO Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com.